Hello everyone. Today we will consider two problems involving separate sets of pulleys. Let's get started. So this is the first problem. We are given a system of pulleys which are balanced by a force of 20 newtons and the weight of G. And the weights of the pulleys themselves is negligible. So we have to find the weight of the block G. Well, let's look at all the forces acting on the system, specifically the tensions in the ropes that are holding this system together. Okay, so if we start with a 20 Newton force here, the tension across this rope should be the same, right? So this is a one rope, so force F acts here that's attached to the block. Now you're pulling this pulley by a force F and a force F, so this pulley must be held by a force of 2F. If the tension on this rope is 2F, tension on this side is also going to be 2F. So the pulley must be held by a force of 4F. Now, if you're holding a pulley by a force of 4F, and it's being held from the two sides of the same rope. So the tension here has to be 2F and 2F because the tensions here have to be equally distributed, otherwise pulleys start moving. So this the total force in pulling pulley up must be equal to the force that's pulling down, and that means the tension in the rope has to be 2F, so it's balanced by force of 4F pulling it up. Now if this tension is 2F, tension across this rope is going to be the same, so this will be 2F. Now let's write down the weight of the block G. Weight of the block G is being held by force F here, by a force of 2F, and by a force of another 2F. So in total 5F. That means weight of the block has to be 100 newtons. And that's it for this problem. Let's look at another system which is slightly more complicated but very similar in its approach to solving it, right? So again, we're given a system of pulleys. There are two weights that are attached as shown in this figure, and again, pulleys are weightless, so we have to express the weight of a block G in terms of the weight of the block P. We're going to do exactly the same thing and start identifying the forces. Let's assume a tension force on this rope is T. Then it has to be T on this side as well. That already tells us that weight P is being held by 2T, right? T plus T gives us 2T, has to be equal to the weight of P. But we are not done yet. So we're going to continue along this rope, and if this tension is T, tension here must be, since it's the same rope, it has to be T as well. That means 2T are pulling this pulley down, so it has to be held by a force equal to 2T. So the tension in this rope is 2T. The tension here must be the same because it's the same rope, which means this has to be 2T and it's attached to the block. Okay, if this is 2T and this is 2T, we are pulling the pulley down with a force of 4T, which means it must be held by a force of 4T for it to be in equilibrium. Right, so you have 4T here, the tension of the rope here is 4T, which means the tension here must be 4T, and this is attached to block. G, that means it's being held by these three ropes, and we can easily calculate G in terms of T. So it's going to be 4T plus 2T plus T. In total, it's 7T. So G is equal to 7T, and P is equal to 2T. That means G must be equal to 7/2 P's. And that's it for this problem. Thank you.